There was an enormous explosion in the entire field of mass spectrometry to the point where it essentially converted almost overnight from a vacuum-based ionization technique to atmospheric. The driving force then became sensitivity improvements. And this, of course, was coming from the people using the equipment.
It was changing. You were used to your HPLCs running all night. Suddenly you had this new piece of software and hardware. People had to understand what the data was showing, but it was the speed of that. And that's why they adopted it. So instead of getting a result from one sample in 18 hours, you were getting it in minutes. When you look in the bigger picture of that, it means you were getting through all the studies faster, people were getting the results quicker, so they were making faster decisions, and it was helping them move the whole industry on.
SCIEX always seemed to have that little bit of extra edge, and they would always come out with, we've got a new instrument, it's 10 times more sensitive. And you sit there and go, how the hell are they doing it? So you try and compete against that, and you always found that they're just ahead of the curve from everybody else.
So we knew for sure that the days of single analyte was kind of out of the equation now. People wanted to do more and more analyte quantitation simultaneously, and that's what led to not only the development of the Turbo-V with respect to ionization, but a lot of improvement in the ion optics.
The Turbo-V was one of the first, if not the first, ion source where background noise was reduced because of the design of the ion source. I think our competitors reacted to us more than we reacted to them because we were the leaders at the time and still are.
Trying to drive to lower and lower limits of quantitation. It was a frantic research effort on everybody's part in the industry, putting things like bigger vacuum pumps. That was a model we called the API 3000. Quickly following on the tail of that was trying to figure out how to create more ions inside the ion source at atmosphere. That led to the API 4000.
By the time they came out, I would say the SCIEX was really entrenched in the industry, and it was the gold standard.
That was an enormous jump in sensitivity at conventional flows, almost 2 orders of magnitude in many cases.
The increased sensitivity is really what excites me about it. It's the ability to see ultra trace levels of particular molecules and ions that you didn't know were there.
It became clear to us that the end was in sight. And if you look at the graph of sensitivity improvements over time with each successive model, you see it reaches an asymptote. It's still going up, but it's going up slower. It's not over yet. There's still more to be gained, but that clued us in to the fact that we had to look elsewhere.